Hello, and welcome to episode 15 of the Sci-Fi Podcast. From Bloomington, Indiana, I'm Nick Zoutra. I am very pleased to introduce our guest for today, Dr. Anya Plutynski of Washington University in St. Louis. Anya is a historian and philosopher of biology with interests in the history and philosophy of medicine, general philosophy of science, and biomedical ethics. She has written on the role of modeling in science, scientific explanation, metaphors in science, abduction, appeals to parsimony in evolutionary theorizing, and the role of chance in evolutionary biology. Her co-edited book, A Companion to the Philosophy of Biology, is a collection of concise overviews of philosophical issues raised by all areas of biology. Her forthcoming book, Explaining Cancer, develops a view of cancer as a heterogeneous natural kind and uses cancer research as a case study for testing competing philosophical views of causation and scientific explanation. Other research interests include evidence-based medicine, biomedical research ethics, particularly issues surrounding risk communication, overdiagnosis and overtreatment, and biodiversity conservation. And here to help me introduce and provide some context for my discussion with Anya on her current work with cancer research, I've brought in my good friend Alex Campbell, graduate student in history and philosophy of science, who is going on to medical school. Well, Alex, welcome to the Sci-Fi Podcast. How are you doing?
Thanks. It's good to be here. I'm doing quite well.
Great, good. Great to have you. Well, Alex is currently taking a graduate course on the molecular biology of cancer, and I thought it might be pretty informative for him to come on and give us one or two key insights into what is going on in modern cancer research and what sorts of things he's learning in the course. So, Alex, why don't you fill us in? What are you learning?
So, two of the most exciting things that are going on in modern cancer research. The first would be the use of precision medicine to treat cancer. And what I mean by precision medicine is instead of viewing what a patient has as, say, lung cancer, it's taking a biopsy of the tumor in the lung and seeing what genes have been mutated, and then treating those mutations rather than treating it as a specific disease type or category. So, per se, upon doing this biopsy, you could find that one of the mutated genes was typically found in stomach cancer. So that would suggest that the clinical approach should be using a stomach cancer drug to target what would originally be targeted as lung cancer, because you're targeting it precisely on what genes have been mutating and what are driving these mutations.
Okay, and so what is the? So can you maybe fill me in a little bit, or what is the main benefit then from using this approach as opposed to looking at the as a disease construct?
Well, the main benefit is if you were going to just treat, say, one type of lung cancer with the drugs developed originally from that lung cancer, it might not have the genes mutated that those drugs target. So you might not actually be treating the cancer versus treating the discrete mutations that have been identified from taking a tissue sample, matches them up with the drugs. And what you find is the populations that undergo precision medicine treatments live about twice as long as the populations that don't. Again, a lot of them, the cancers come back very aggressively, and that's just unfortunate. That happens in a lot of cases, though.
Oh, yeah. Oh, great. Well, any other insights you can share?
Yes, one of the other things is using some of the new updates to the hallmarks of cancer. So one would be inflammation, increasing the risk of developing cancer. Anything from celiac disease to Crohn's to anything that causes chronic inflammation is going to put you at a higher risk for cancer. That's going to obviously vary by the intensity of inflammation and duration, but it's looking at what inflammation does, providing the environments for cancer to grow more aggressively, to develop. Yeah,
so I was going to ask my follow-up. What does inflammation do? Like, what is particularly risky and or as a result of inflammation?
Inflammation is going to damage cells in a way that promotes cancer. So it's the same thing that you would get from getting sunburn. It's going to cause damage to DNA. It's going to increase the risk of cells replicating that should not replicate.
Okay. I was curious. So we've talked a little bit about this course over time, over the course of your semester. What's one of the most surprising things you've learned from taking the course?
I'd say the most surprising thing is how little we know right now, not we in the course as a general scientific population, about the mechanisms of some of these cancers. Every other line in the textbook, basically, and this is not an exaggeration, is we don't know what precisely is going on here. But one of the greatest things that's coming out of this is the scientific population studying cancer knows what they don't know. They know what to investigate. It's not going to be easy, but it's not fumbling in the dark. They have an idea of what they need to solve. Whereas this just wasn't how things were done 20 years ago before you had the Human Genome Project. We didn't view cancer in the same way.
Well, very, very nice. Very nice, Alex. And for our listeners, if there's, one or two recommendations in terms of what we could do in terms of prevention from developing or acquiring cancer, is there anything with which you can recommend that you've learned in the course?
Well, I would preface this that I'm just a graduate student.
Yeah, of course.
However, listening to the clinical insights from the public health department in the U.S., from the NIH, the CDC, things like wearing sunscreen when you go outside, these aren't just whims that doctors come up with. These are well-attested preventions and preventative tools that are going to hopefully reduce your risk of getting cancer.
Yeah, great. All right. Well, Alex, thank you for coming on and sharing a little bit about this course. We'll be sure to have you back on for future episodes.
Thank you.
But yeah, would you mind going ahead and introducing our guest for today?
Absolutely. And without further ado, here's Anya Plutynski.
Well, let's take a step back and start back at the beginning. So, where did you grow up, Anya?
I grew up in California, Los Altos, Silicon Valley.
Los Altos. Wow. Okay. Was this in Silicon Valley? How was Silicon Valley? What was it like back then?
Definitely not as shishy as it is now. I go back and I'm kind of shocked at. It's a lot more crowded and expensive.
Yeah. And I imagine the tech boom was maybe starting to come up. Things were going on, certainly, around that time.
Sure, yeah. I had a lot of friends whose parents worked in computers and engineering, but nowhere near, I'm sure, what it's like now. So every other person works for Facebook or Google and what have you. So
Sure. Did your folks, were they in those kinds of businesses at all, or what were they doing?
My dad was an aerospace engineer, and my mom was an English professor.
Wow. Okay. Did your mom, was she teaching at one of the universities nearby, or?
She taught at several different community colleges.
Oh, great. Okay. So did you, growing up, was there, parents with some pretty academic-oriented careers? Was there any interest there early on?
Interest in academia?
Well, I said maybe. So we have English, we have aerospace. I suppose math, science, etc.
Well, I was absolutely convinced that I never wanted to be an English professor because my mother was always grading papers.
Oh gosh. Was she just, did she love grading? Was she just so happy about it? Yeah, no, I could imagine not.
But definitely my parents were academically inclined, and we had a lot of books in the house, and I argued with my dad about science all the time, and so yeah.
Oh, okay. Do you remember any of those arguments, or those discussions early on?
One thing that particularly struck me, so this was during the Cold War. I'm that old, really. And my dad, his first jobs were doing things like spying on the Russians. You know, he put some of the satellites up that watched the bad guys. And so one of the things we talked a lot about was the Cold War and the rationale of the Cold War. And he had read Hiroshima in college, and then he went out and helped to build satellite-guided missiles for his first job.
Wow.
And so, like, we talked a lot about the rationale for the Cold War. Like, why would it be a good idea to build up a set of satellite-guided missiles to prevent other kinds of wars from happening? I mean, it was an interesting. Yeah. So, yeah.
That's fascinating. Were some of the things with which your dad was working on, were they things that couldn't be shared with the family?
My dad had a security clearance. Yeah.
Well, that's great. That's very interesting. Okay. So growing up, all right. So growing up, and I mentioned, so what other things were you interested in growing up?
So I loved to read. I read voraciously, and I loved music. I played the piano growing up, and I loved ballet. So I did a lot of arts and theater and stuff. I was a theater geek in high school. Oh, really? Yes, a little bit of the same. A little bit. What do you recall? Which I don't know. Did you do any shows in middle school, high school? It's really embarrassing. I was. I don't even know if I want to go there, but yes, I did quite a lot of theater in growing up. Yes. Cool. Oh, that's fine. That's fine. Yeah. No, my starring role was Nicely in Guys and Dolls, which is the quintessential. Well, one of the quintessential like musicals or whatnot. It was a great role. It was a lot of fun. I can hear the voice. Yes, definitely. You've got the theater voice. Oh, cool. Yeah. We have to find our place somewhere in school, and it's not a bad place to be. Well, sure. And you said, and so ballet was one of your passions. I did. I loved ballet, and I did it all through, growing up. And but I was never quite good enough to do it seriously. The competitive. Yeah, I can understand how competitive it is and continues to be. But I love to dance, and I actually think theater is really good preparation for philosophy. Really? I'm curious. What are your thoughts on that? Well, because certainly when you have to get up in front of a group of people and keep their attention and tell a story, and that's theater. I mean, that's performance. So it certainly is. It certainly is. I'm trying to find. I'm sure there's plenty of other analogies or lessons we could learn or draw from theater. Yeah. So okay. So eventually we're getting into your starting to be interest in philosophy. Where from growing up and then going to undergrad. Where did you go to undergrad? So I went to University of Chicago. Oh, cool. Okay. How was your time there? I loved it. It was the most intellectually stimulating time of my life. I was interested in everything. I had great professors. Everyone at U of C, this is sort of old-fashioned, but they have to do the core curriculum, which is the Great Books program. And so I got to read Aristotle and Kant my first few weeks in college, and I loved everything, and I just had a great time. Did you have a favorite book that you read back then? Or maybe a couple, or what if one comes to mind that you're like, I remember reading my sophomore year and this was incredible. It opened my eyes, or something like that. Gosh, I think everything. I mean, I was exposed to such amazing stuff. I took this class with J.Z. Smith, which was sort of a core social science class. And we read Marx, Weber, Freud, and Durkheim. And that just blew my mind. Every single one of them, I just felt like, wow, this is fascinating. I really enjoyed it. Absolutely. So what were your majoring in? I don't know if I can explain it much better. It's been over 20 years. Sure. What were you studying initially? What did you go into, or what were some initial thoughts in terms of what you wanted to study, what you wanted to do? So I started out as a physics major. I amazingly enough tested into physics for physics majors, which I was kind of shocked by. And so I thought, well, maybe I should try that. So I was one of 2 women in a physics for physics majors class, which was agony.
Oh, geez.
And so I lasted like 1 semester on that, and then I sort of took just everything. I took lots of different classes, but I was briefly a South Asian Studies major, and then I was a philosophy major. Largely after taking classes with Dan Garber, who turned out to be my thesis advisor as an undergrad.
Yeah. So what drew you away from physics and to, or maybe including physics, to philosophy?
I took some great classes in history and philosophy of science with people like Howard Stein and Bob Richards and Dan Garber and Arnold Davidson. And my first class in philosophy was Arnold Davidson's class on history of sexuality. So the first philosophy I read was Foucault. And I thought that's how philosophy was written.
Oh, boy.
A rude surprise to learn that, oh, no, I don't want to write like Foucault at all.
Yeah, maybe if you grew up in France, you would have that. But your first couple of philosophy classes. Oh, wow. So I haven't read the History of Sexuality book. What do you recall the kind of the general ideas going about in that book?
Well, I just think it was interesting to think about how we conceptualize sexuality as growing out of a certain kind of scientific worldview, and that had changed so much. I just thought it was really interesting to think about how science intersects with our conception of ourselves, as with our agency. I was really interested in college in sexuality and agency and freedom and I mean, I was kind of, how much does our biology affect who we are and what choices we make? Okay. So that was something that kind of drew me through into philosophy and into thinking about freedom and free will and stuff like that.
Yeah. So I see in some of the other things you'd mentioned that, does biology affect who you are? You had been influenced by a few other books, such as The Dialectical Biologist, by Levins and Lutenton, and Our Genes, Us as well. What was it about those books that particularly interested you?
Well, when I was writing my undergraduate thesis with Dan Garber on Spinoza, I started reading around on biology. I know that sounds very strange. I was really interested in this problem of freedom in Spinoza and how he understands freedom and necessity. And I was really interested in these questions about, well, we're biological organisms. Clearly, what we do, what decisions we make is affected in part by our biology. And I picked up The Dialectical Biologist, and I picked up Our Genes, Us, and I just got very interested in these questions about genetics and causation. And though I didn't really even know about philosophy of biology as a field at that time, it wasn't something I was aware of. I was really interested in how biology shapes our view of ourselves. So
very nice. Okay, great. And do you recall your thesis, your undergraduate thesis project?
Yeah, it was reconciling freedom and necessity in Spinoza's ethics.
Oh wow, okay. So what was sort of the main line there?
Well, let's see.
I know it's been probably 20 years.
It's been some time now. Roughly, I think that what I tried to do is make sense out of what he understood as freedom, which is kind of the usual view of freedom. We're all necessitated according to Spinoza. Every action that we take is necessitated by the laws of nature. And yet he thought that we could be free sort of in mind. It's a kind of Stoic view that someone could be even, tied in chains and yet, if they took the view of God, sub specie eternitatis, like from the perspective of God, if you understood how the laws of nature and how the initial conditions determined where you are and how you chose what you chose and how you came to be where you were, that somehow that would give you a sense of freedom. And so that was what I tried to articulate in my thesis, is what freedom meant in Spinoza.
Great. So And so is this Spinoza? Is it a form of compatibilism? Is that right?
Yeah.
But you were offering kind of a particular view of this compatibilism, or like a way of understanding it. Cool. Yeah. Great. Well, that sounds like a great project, and certainly I can relate with having some questions related to freedom of will and as well as the way in which what science can say about it is certainly interesting to me. So, in thinking about your undergraduate work, what was going through your mind in terms of after undergraduate? What were you wanting to do?
Frankly, I didn't have very clear ideas. I knew I loved philosophy and I loved Dan Garber's classes, and I thought that I wanted to do early modern philosophy. I had some great classes on Kant, and I thought maybe I want to work on Kant, and so I applied to a bunch of graduate programs, mainly thinking I was going to do early modern, and I went to Penn because Paul Guyer, and it's a great program there for early modern. At least it was when I was applying for grad school. I don't know if it's known as much for that now, but so I went there, and then I just took a lot of different classes. I kept being interested in lots of different things, and I took biology, I took history of biology, and I just started migrating over to history and philosophy of science, even though that wasn't an area that they had.
So a lot of different folks from philosophy of science come in. Well, there's a number of different ways, but the two main ways seem to be people begin in the sciences and then they find their way into philosophy, or they might begin in philosophy and find their way into the philosophy of science or whatnot, and then eventually meet. But for the former, a lot of folks who begin in the sciences, they're not as exposed, or they're not as rigorously exposed to doing early modern philosophy. What really attracted you to doing that initially, and what do you see as perhaps the value for philosophers of science by taking those who do early modern philosophy seriously?
Oh, well, okay. I definitely got the very strong impression that one of the things that I think that, unfortunately, the way that Descartes, for instance, is often taught is you just read the Meditations, right?
Yep.
But Descartes was a scientist. He was really interested in replacing Aristotelian physics. And one of the things that really excited me about taking classes with people like Dan Garber, and then eventually when I got to Penn, Gary Hatfield, was the realization that so many of these early modern philosophers weren't just interested in the problems of philosophy as we narrowly conceive them now, like as sort of traditional M&E questions, but they were really motivated by rethinking the scientific worldview as it had been given them and trying to come up with a different way of understanding the natural world. And so I realized, philosophy and science are really tightly intertwined. I mean, that was something that was kind of a theme all the way through my undergraduate education and graduate school. And so I initially didn't see this sort of transition into philosophy of science as that big of a leap from early modern philosophy, because early modern philosophers were natural philosophers. They were scientists. They were naturalists. They were interested in these scientific questions and not just, I think we think of them as,
we certainly do. Yeah. I think I think we mischaracterize them. Absolutely. I think that's a really insightful comment to make. And I think that's something I will certainly carry on with me in terms of, remembering them, and then what that means in terms of how close these two disciplines are. I think currently it's maybe not the case. We don't typically think about that as such, but okay, that's really good. So you started working on early modern, and so what were you? So you were doing that, and then were you thinking about going to graduate school, or what was your plan?
I applied to graduate school. Maybe this is a bad reason because, well, I love philosophy, but I also wasn't sure what else to do with
that. I understand. Yeah. What do you do with the philosophy major?
Yeah. And I just love being in the classroom, and I loved learning, and I thought, here's a way I can keep learning for the rest of my life. I can just do academia.
Yep. I can empathize with that. Yep.
Yeah. So, but I think at the time also the job market wasn't nearly as rough, and I just didn't have the sense of how difficult I think it has become in terms of getting a job and keeping a job and all those things. Yeah, it's changed a lot. So.
Yeah. Oh, keeping a job. That's interesting to maybe talk about, I can imagine. And you said you worked here with Peter Schwartz. Is that right?
Yeah. So
Okay.
Peter Schwartz was a more senior grad student when I got to Penn, who was doing an MD PhD. He did his undergrad at Harvard, and he took classes with Stephen Jay Gould and Lewontin.
Oh, wow.
I really admired Peter, and he and I just sort of started working through Sober's conceptual issues in philosophy of biology together. We got really interested. I was really interested in biology, and he had an undergraduate biology major, and so we started talking. We had a lot of fun, and there was this guy named Kelly Smith, who at the time I think he was teaching somewhere in New Jersey. I can't remember, but he's a philosopher of biology, and so we all started meeting, and I started taking classes in genetics in the biology department. I had like so my second or third year in grad, I think it was the second year, I was like, I don't know if I can do this. Maybe I'll apply to med school. So I started taking biology.
Sure, yeah. So mid PhD, you're like, well, I don't know. I can understand.
Sure. So, but eventually I realized, okay, I finished most of my coursework, and I had taken so many biology classes by then that I actually had almost half of what it would take to get a master's in biology. And I sort of wiggled my way in. I finagled my way into the master's program in biology at Penn, and I got a master's working on evolutionary genetics in Paul Snagowski's lab. So I did a project on the evolution of mutation rates.
Very nice, very nice.
Yeah.
So at this time, I mean, coming from, was there a point in which there was a shift from, going in with early modern to thinking about philosophy of science, or was there still the plan, to get go into a more traditional philosophy position?
No, I definitely shifted into philosophy of biology by that point. I realized that there were all sorts of really interesting conceptual issues in biology and in history of biology that could be a dissertation project. And so that became actually my dissertation project, was looking at the history of two major figures in evolutionary theory and trying to make sense out of why they were arguing and what they were arguing about, and then using that to address some more general questions in philosophy of science about modeling and explanation.
Okay. Do you want to share what were some of the your main claims you were making in your dissertation?
Well, let's see. I was trying to figure out, why do biologists argue like they do? That's like John Beatty's question, right?
Yep.
I was really interested in this debate between Fisher and Wright, who are two of the major figures in the origins of evolutionary genetics. And I think I got interested in them really initially because they were disagreeing about something that I had long been really interested in, the role of chance in evolution. And I think going back to my interest in freedom and decision making and biology, I was really interested in, on the one hand, Sewell Wright's emphasis on chance and evolution versus Fisher's sort of hill climbing picture of evolution. And so I got really interested in this question, like, why were they arguing? How were they arguing? What was going on? And so my dissertation ultimately was trying to make sense out of both the nature of explanations in evolutionary genetics and the nature of disagreements, why people argue, what are they arguing about, how different presuppositions inform model building and what models can do for us, that kind of thing.
Very, very nice. Very nice. So, upon working on this dissertation, what was next? Like how, I'd asked to follow up, how did you get your first job?
So I think it was completely accident and magic. I was not finished with my dissertation, but one of my committee members, David Magnus, is he's now teaching bioethics at Stanford. But at the time,
I've heard that name before.
Center for Bioethics at Penn, and he's written a few philosophy biology papers long time ago. But he happened to know that there were a few jobs in philosophy biology just at random, like a year before I had almost defended, and he said, apply. How many more jobs in philosophy of biology could there be? And, so I applied, and I applied to 3 jobs, and I got 2 offers. I was
wow.
So I got this job at Utah. It was an excellent fit for me.
Was that University of Utah?
University of Utah, that's right.
Yeah, okay. Yeah, they have some strong philosophy of biology there. Yeah.
Yes, in fact, I was in hiring several of them.
That's probably what, maybe perhaps I'd be interested to hear. I was always curious as to why, how the philosophy of biology department has kind of grown at Utah. So perhaps we could talk about that. Well, that's good. It's always good that magic can happen and positions can happen. So great. So what was it like making the transition as a faculty member in philosophy?
Terrifying.
Okay, good, good. Yeah, what was terrifying?
Well, so the first time I taught my own big class, it was like 70 students. I taught bioethics at Utah. I would wake up at 5 a.m. and type my notes, single-spaced, 8 pages of lecture notes, and I would stand shaking in front of the classroom, like terrified lecturing. But I think, I got used to it eventually. Utah is a great place. When I was there was only Steve Downes was the only other philosopher of science and philosopher of biology, and Miriam Thalos, who does philosophy of physics and philosophy of social science, was there. But Steve was my mentor, and he was amazing. He read all of my papers. He helped me so much. So he deserves enormous credit for that. And also, I think, for building philosophy of science at Utah. It's really become a great place to do philosophy of biology in particular. So
so how did how did that come about? How did the decisions, or how was it so fortunate that University of Utah has become a place that has attracted philosophers of biology?
Well, I believe we had an external review, maybe my second or third year there, and the reviewers suggested, and I'm very grateful that they did. I can't remember who they were, actually. Maybe it was Muriat Ayadi. I can't remember. But anyway, they said that we should build to our strengths. And our strengths at that point were philosophy of biology and bioethics, because we had at least 2 or 3 faculty in both of those areas. And so we made a case to the dean that we should keep hiring in those areas. So we've been, or at least when I was there, we hired Jim Tabery, Matt Haber, and then eventually we kept trying to hire in bioethics. That's something that I know that they've been trying to build as well. But that was the goal.
Cool. Okay. And so your first few years, you worked there. And how long were you at Utah?
11 years.
Oh, okay. So this is okay. That's great. How else was your experience like? What other things were going on at that time?
One of the great things at Utah is that because they have such a strength in bioethics, there's a nice connection with the medical school. So I got to know lots of people in the med school. There's a fellow there named Jeff Botkin who works on genetics and bioethics.
Oh, great.
He's fabulous. Yeah. And so there's some great people in the medical school who are interested in bioethics and in the philosophy department. And that was a wonderful connection to have. And I was very grateful because I got to teach some classes to medical students and get to know medical students. And then, so I think it was shortly after tenure, 2009, I got cancer when I was there. I got breast cancer.
Oh, I'm so sorry.
No, I'm very grateful that I caught it early and I got it treated and I survived. So, but one of the great things about being at Utah was that, first of all, I should just say that all my colleagues at Utah were just an amazing support team for me when I was going through that, and they deserve, my great. I'm immensely grateful for that.
Oh, that's fantastic.
Yeah, and what was also really great was that because we had that connection with the med school, I got to take classes up in the med school. So after I finished treatment, I just started. I was just fascinated with cancer. Like, why the heck did I get cancer? I was 30. I think I was 36 at the time. I was sort of taken aback. I didn't have any family risk factors. I was never a smoker. And so I was sort of like, why the heck did this happen? I want to learn how cancer works. So I started taking classes in the med school and I got really interested in cancer, and that became my next research project.
Really? Okay. So what was, you mind, telling us a little bit about this research project?
So I have a book, I have a contract with Oxford and it's been accepted. I'm soon to finish it, knock on wood, on cancer and cancer classification and cancer explanation. I realized that there there are a few people writing about it. There were a few people writing. There are more people writing about it now. But at the time, the only people I knew who had been writing about cancer and as a philosophical question, issues about classification and explanation were Loss, What Genes Can't Do, that book that came out, I think it was 2007, maybe 2004. I can't remember. Mm-hmm. And this woman named Marta Bertoloso, who's in Italy, had written a few papers, and Christophe Malatier, and I believe Matt. No, I'm misremembering. Anyway, there were like only a few papers about cancer, and so I thought, okay, here's something that there's so many interesting things to say about this. It's such a complex disease. The biology is fascinating, and it's connected in so many interesting ways to evolution. Mm-hmm. And environmental issues, and so I just realized, okay, here's a project. So that's my book project.
Yeah. So you mentioned you create this view of cancer as a heterogeneous natural kind. So for our so could you maybe unpack that a little bit and just in less philosophical terms? What do you mean by that?
Let's see. So as I think many of your listeners know, biology presents some interesting challenges for natural classification. So the sort of traditional essentialist view of natural kinds, where each kind has an essence or sort of essential property, doesn't quite work for things like species or genes or what have you.
Yep.
And so various philosophers have defended, for instance, the HPC or homeostatic property cluster view of kinds, right, as a nice alternative, which sort of retains natural classifications in biology. So we can still be realists about species, maybe, but we don't have to commit to sort of naive essentialist views about natural kinds. And I thought, okay, does that work for cancer? And initially I thought, yes, it does. So I was defending an HPC view of cancer on the first draft of the chapter on cancer classification. But then I started getting worried about what these mechanisms are that are supposed to unify cancers or cancer as a kind. And I also got really puzzled by how we count up cancers, because it turns out that there are lots of different ways of classifying cancers, that different scientists use different modes of classification for different purposes. Mm-hmm. And some of these classification modes are cross-cutting, which created some challenges. And there's all these promises that are made about genetics and genomics as giving us a perfect scientific classification for cancer, and I was somewhat skeptical of these. And then on my nth draft of the chapter, Ali Khalidi came out with his book, and I read it and I thought, so he defended the homeostatic property cluster view. Mm-hmm. He said cancer is a natural kind, and I said, okay, now I have someone to attack.
Perfect.
Because I had been struggling with these issues myself. I was really confused about what the mechanism was and how the mechanism, which mechanisms, right? Because there are hundreds of mechanisms that cause cancer. Which are the ones that make cancers or help us classify cancer the right way?
What makes cancer?
And so what the chapter is really about is addressing this question of how we count up kinds and what kind of properties or features make kinds the kinds they are. How many cancers are there? Hundreds, thousands, millions? Is each cancer itself a natural kind? Because each cancer evolves. So, right, that was the project of that. Yeah.
Very exciting. And you say this is a book that will be eventually pretty soon coming out?
Yeah. So the response to Khalidi is actually in a paper that's still under review at Synthesa and will come out someday. And then the book, on its way. Eventually.
Explaining cancer. No, well, I'll be certainly looking forward to that. I can't help but draw. I have my own personal interest in issues with explanation and classification of psychiatric disorders, and so a lot of the concerns there is work concerning are mental illnesses natural kinds, and if they are, what kinds are they, and such like that. So I couldn't help but draw some analogies to maybe some similar philosophical issues related to the ways in which we describe, explain, and classify cancers, which are and interesting enough of finding, genetics and genomics giving a perfect explanation. I think we're pretty far away from that for mental illness. And I'm not sure if anyone is claiming that, but I could certainly see that folks for cancer might, in the sense that I don't, and I'm not sure necessarily why they might have a better reason to do so. But yeah, I just thought I found that interesting.
Yeah, no, I mean, there's a better case to make for genetics being the tool for classification of cancer, because cancer, I mean, the most obvious mechanism, if you're going to pick out a mechanism for cancer, it's the mechanisms of breakdown of regulation of cell growth. Mm-hmm. And one of the major causes, the sort of explanatory bottleneck that might be the one that we would pick out as demarcating cancer as a kind, is genetic mutations, right? Yep. But it turns out that it's a heck of a lot more complicated than just adding up a number of mutations and then you get cancer. It turns out that a lot of things have to cooperate for you to get cancer. So you can have a lot of mutations but not get the disease. And so, yeah. So there's some really interesting questions here about how we pick out causal explanations. And I think this is nicely connected to the whole causal selection problem. So actually the chapter following the chapter on classification is about the causal selection problem and is cancer a genetic disease? Because a lot of people will just say it's a genetic disease because it's caused by mutations.
Sure.
But it's, yeah. So picking out levels of explanation here is really interesting and a hard problem. And I think that's nicely intertwined with this problem of classification. And I think in psychiatry as well, clearly, right?
Oh,
it's
yeah.
very tempting to look for genetic explanations. But, you know, are we addicted to cigarettes because we have genes for addiction? Or are we addicted to cigarettes because we smoke the cigarettes?
Yeah, good questions. Yeah. Well, I'm thrilled. I'm very excited for this project. So is this something that I imagine you're continuing on? So I'm curious about the transition from Utah to Washington University in St. Louis. How did this come about?
Well, I was invited to apply, and I thought, what the heck? Why not? And I honestly did not think I would get the job. I was like, maybe, I don't know. And then I did, and then I got it. And so, I ended up coming. It was very exciting. I mean, I just have amazing colleagues here.
Yeah.
One of my dear friends, Ron Mallon, taught at Utah and ended up moving to WashU. And you know, I have immense respect for Ron, and I just think it's a great department, and it's really fun to have such amazing colleagues here. So.
Oh, that's great. That's what's you know, for those not maybe super familiar with Washington, what goes on in the philosophy department? What are its strengths? Is there anything particularly special about the department that you like?
So the program that's most well known at WashU is the Philosophy, Neuroscience, Psychology program. Mm-hmm. And the people here who are in that program are John Doris, Ron Mallon, Carl Craver, Lizzie Schechter. And it's a great place for doing interdisciplinary work. And one of the things also that attracted me to WashU, frankly, is the medical school. It's one of the top medical schools in the country. Mm-hmm. And I've made friends with and actually published with some people in the medical school and have gotten to know them pretty well. So, yeah, it's a great place for people who are interested in science, but also in medicine and neuroscience in particular, and psychology. Yeah,
I mentioned, you know, taking some medical school courses in Utah and now publishing. What's it been like working alongside medical researchers or, I suppose, medical students?
Well, I had lots of practice in being a naive philosopher walking into a lab at Penn. So,
sure.
So I'm very good at that role. I mean, I think if you're just intellectually curious and you ask questions and you keep trying to learn as much as you can about the science, I've found that engaging with scientists and physicians and researchers is the best. I mean, researchers in biomedicine has given me some of the best philosophical ideas I've had. I actually find talking to scientists is sometimes more philosophically exciting than talking to philosophers. I mean, they're just very excited about their research, and learning this stuff is just fascinating. And
Yeah. Well, I certainly think that's the case. And we all, you know, some of us scientists, philosophers, we can think in different ways. And, there's a lot of rich content and fun stuff to talk about with the scientists themselves. Okay. So now at Washington University, are there any projects you're currently working on? I imagine is the Explaining Cancer book, is that pretty much taking up most of your time, or are there other avenues in which you're exploring?
Yeah, I've also been contributing to a variety of different edited volumes, which has slowed down the cancer book a bit, but fun, amazing projects. So I got to interview this woman named Mia Bissell, who's a cancer researcher at and contributed to an edited volume by Mike Dietrich and and another guy that's coming out. It's a series coming out with the University of Chicago Press. The first two were outsider scientists and another one. Anyway, this one's going to be sort of dreamers and visionaries in life sciences. So I love these edited volumes because they combine work of historians and philosophers of biology, and they're asking questions about people who are doing kind of marginal science, strange science, stuff that is outside of the mainstream. So I got to interview Mina, and she's amazing, and she's my hero, and I had a lot of fun doing that. So that paper was great fun, and I contributed to an edited volume on foundations of molecular medicine, and I edited a book with Justin Garson and Sahotra Sarkar on biodiversity. Oops,
sorry.
Still there?
Sorry. Yeah, the audio is going out a little bit. We'll keep it. Okay. I think it'll be okay, but I think sorry.
Right. Anyway, so lots of different projects going on. Stuff on inductive risk and cancer screening, and so I've been doing a lot of different. Probably too many things.
It all sounds very exciting. That's great. And you mentioned sort of like different kinds of science, or like what do you mean by that? Or like the more interesting, not run of the mill kinds of projects in the book or the collection you were talking about?
Oh yeah. So Mike Dietrich and Oren. Anyway, sorry. I can look it up. But anyway, these two guys wanted to publish a series of volumes that were looking at sort of outsider or non-standard sciences. Mm-hmm. So, I mean, the sort of when you look at history of biology, the temptation is to look at all the major figures and so let's look at Ernst Mayr and Darwin. I mean, so much has been written on Darwin. It's an industry, right?
Sure.
But what they wanted to do was look at figures who were sort of marginal and criticized and outsider and maybe coming from different directions. And that kind of history can actually be really interesting. And one of the things about biology is it is such a kludge. People come into biology from physics and mathematics and cybernetics, right? And they change biology in lots of interesting ways. So they were interested in looking at that question: as how is biology sort of a mishmash, and So that's the kind of thing that they're doing.
Cool. Okay, well, looking forward to checking those out as well. So I had asked you this over to email, and I think you had some pretty interesting insights. Generally the question concerning, what are some of the greatest challenges facing philosophy of science today? And I wanted to hear your thoughts on that.
I'm so glad you asked me that over email and in advance. It took me a while to think about an answer. Okay, so I think I have two or three main things to. First, I think philosophers of science need to do a better job communicating with and learning from other areas of philosophy.
Yep.
So I think it's very time for philosophers of science to talk amongst themselves and to maybe be impatient with analytic philosophers who do sort of traditional M&E, or for analytic philosophers who do traditional M&E to talk amongst themselves and get impatient with philosophers of science. So I think there's a lot of misunderstanding with communication, but we could learn a lot from each other if we get better at that. And I think that's something we need to do better.
Absolutely.
I don't know how to do it. And I can diagnose the problem. I think that philosophers of biology tend to be pragmatic, and they're really interested in real-world problems and learning about science. And I think analytic philosophers often see what we're doing as your science reporting. And really, the challenge is to communicate what we do in a way that helps make clear to people who do traditional M&E why what we do matters and how it's relevant to questions and foundational questions in epistemology and metaphysics. And I think this goes back really to the history of naturalized philosophy of science and what it really means to do naturalized philosophy. Are we doing something that's continuous with science? Are we doing science writing? How can we balance criticism with with engagement and learning. And I think that's a big second problem is how do you balance being really informed by current science, but also being critical and reflective about it at the same time. Doing that, I think, is really difficult. Mm-hmm. I don't know if I've achieved a balance there, but I think it's really hard to do.
Did you, in your own experience, I mean, did you were you someone, I mean, you came from, I suppose, both a science and a philosophy background, so that's a little bit different than some. But, did you always hold this position, or was this something that you kind of have come to realize from being in philosophy departments, from doing philosophy of science, like, we really need to work together?
I think it's hit me really hard since I've come to WashU. I think I was sort of, how to put this, but I had it kind of easy at Utah because everyone got what I did, and I didn't have to convince anyone that philosophy of biology was philosophy. More or less. I mean, it was like, oh yeah, of course it's philosophy. But here, I think in most sort of mainstream departments, you do have to make a case that what you're doing is actually philosophy. And I think I didn't realize that was something I had to convince people of. But yes, I think being here has made me realize that, some analytic philosophers think that philosophers of biology trying to do metaphysics is absurd. Like, how dare we? And I think I do think that learning how to sort of cross those boundaries and communicate better across these different areas is really important. I think it might be just a generational thing, but I don't think that's just it. I think that we're trained differently. We have different heroes. We have different languages. Just how we write, how we, it's completely different. So I do think that's a challenge. I think there was the first part of your question that I didn't quite answer, but
I think I suppose the second part being what have you? I suppose you've seen, but whether it sounds like, I guess I was curious about whether you've always felt like this connection was necessary, or whether you yourself, I don't know, at a time had been maybe on one side or the other in terms of, I don't know, more pragmatic, or I suppose more traditional M&E questions focused.
No, I think I've always been very. I think that my progress into philosophy of science sort of came through science. I think I didn't realize that there were interesting philosophical questions in science until I started doing science. And I had the great fortune to have professors in biology who were actually philosophically very sophisticated and interested in historical questions, interested in how their discipline evolved. Mm-hmm. And I think that it's unfortunate that a lot of philosophers tend to think of scientists as very naive and flat-footed about philosophical problems, that they think, scientists just, they don't really think critically about what they do. But I think the best scientists do. And if you talk to them and get to know what they're talking about and find out what the questions are that they're really troubled by, you realize that they are doing philosophy. They may not call it philosophy. They might call it arguing about method or arguing about,
sure.
Yeah, they don't call it metaphysics, but they're doing metaphysics. And I think that coming from inside science, you find these problems. I think they're more interesting from the internal point of view than from the external point of view. I think it's exactly when philosophers come in with agendas that they get things wrong. Yeah, right? They find the wrong problems. They locate the problems in the wrong places. And I think that you actually have to talk to the scientists to figure out where the real epistemological and metaphysical issues are. Because sometimes the scientists know what they are. They just don't label them epistemology and metaphysics. Mm-hmm. I don't know how to, if that answers your...
It absolutely. So I know, so the first part is getting folks more connected. What else? What other challenges do you see?
So the third big challenge I think that philosophers of science and philosophers more generally need to address is to do more socially engaged philosophy. And I don't know how to define what that means, but I do think that writing for a general audience, writing more popular work, doing things like radio programs, doing things like editorials, maybe even writing a few books that like not just philosophers would read. would be great, because I think what we do is important and interesting, and it engages with all sorts of really, core issues in politics and today. I mean, how we decide about what to fund and how to fund, and where do we put our energies in terms of public health and medicine and scientific research. All these things I think philosophers can speak to and engage with. But I think that unfortunately we tend to just sort of talk amongst ourselves and live in the ivory tower, and we could do a lot better job of reaching out.
Well, it's even come to me like there's certain editorials or avenues, like the New York Times has they have like the Philosopher's Stone column or something. And that just, I don't know, to me, it just sounds very ivory tower. It does not sound just like person to person engaged. Like where you get like, let's say a scientist who writes into the New York Times or something else. I mean, they usually, it's like, they can sometimes come off as like sort of, authority, like I am the authority, but often it's just like someone who's like, look, I do this work and this is why I care. Whereas it's not like, oh, let's talk to so-and-so who has this, like there's how, so how can philosophers better, I don't know, how can they become more socially and politically engaged?
Well, so the first thing is, I think that something about U.S. culture, that the whole calling someone a philosopher is almost by definition labeling them abstract, obscure, far above. Whereas in other places, I think in France, I don't know. I mean, I'm not an expert on this, but there's a sort of more of a history of public engagement and public philosophers, like philosophers just talking on the radio, philosophers writing articles in the newspaper, speaking to current issues. And I think that maybe saying I'm a philosopher shouldn't be a way to alienate people, and maybe, I don't know, domesticating philosophy by making more public statements as a philosopher. I think that one of the things philosophers do, and I noticed this, is when they do engage publicly, they often downplay how they're trained. They'll say, I'm interested in ethics, right? Or they'll say, because they think that will make them more socially acceptable, engaging for people. Because if you say you're a philosopher, somehow that's, but I think that, I think that's too bad. I think that we should sort of own it. We're philosophers.
Okay,
Yes. And philosophy is something that and maybe another thing to say is we all do philosophy. We just don't call it that.
Yes. Okay. Yeah. I think pointing that latter fact out, I like both. I like the own it. Yeah. So still maintaining like, this is what I do. And this is why, I think it's interesting, why it's important, why it's relevant. But also, connecting that's certainly the communication of science, especially now with like the March for Science coming up in Washington, and a lot of sort of science communicators saying like, we're all we don't all do science, but there are ways we all think scientifically, or certain ways, and that's certainly so everyone kind of feels like a part of the process. They feel more comfortable with it. Whereas maybe even historically, science is not all, people haven't been particularly enthusiastic about science. It's been more of the white lab coat, nerdy person that's not, kind of like, but now it's more, science is something to be championed and cheered. And why not philosophy, I guess?
Yeah.
Yeah. Cool. Okay. Any other challenges you can think of, or we've gone over?
I don't know. Maybe that covers it.
Yeah, I'm sure. Yeah. No, this is great. I really appreciate you putting in the time to think about this. And hopefully our listeners will get something from this discussion.
Thank you so much. It's been a lot of fun chatting with you.
Yeah, you too, Anya. Is there anything else you wanted to share or to say or mention and talk about?
I think that covers it.
Okay.
Okay. Here's one thing. If women philosophers of science out there, you should join the Women's Caucus, the Philosophy of Science Women's Caucus. I've just become co-chair, and I'm really thrilled, and I think it's a great group. And we're going to stop meeting at like 6 a.m. So good. So at the PSA,
was it the women's breakfast? Yeah,
at lunch instead of in the morning. So hopefully more people will come.
Great. Yeah, I think one of our first guests we had on we had Roberta Milstein, who was either the former chair or one of the chairs, or but certainly said a lot of very good things. But I will certainly spread the word, and good to know that the Women's Caucus. Do you guys do anything else in and outside the conference, or is it right now it's mainly during the PSA?
Well, we have a blog called Science Visions, which
cool.
Folks should find online. It's open to the public, and we also we give a book award biannually, I believe, for the best book in philosophy of science. That's also awarded at the PSA. One of the things that I think we'd like to do more is more mentoring. So that's something we're talking about, is how to better mentor women and non-representative groups in philosophy of science to get a wider array of people, a more diverse array of people involved. Because I mean, one of the issues of outreach and socially engaged philosophy of science might be better addressed if we have a more diverse community of people speaking for philosophers. I don't know, maybe.
Sure, yeah.
So that's a goal.
Absolutely. Yeah. All right. Well, thank you so much again for coming on and sharing your thoughts and your story. It was a really pleasure. I had a great time talking with you.
Nice chatting with you, Nick.
Yeah. Have a good rest of your spring, and hope we can cross paths at some time in the future.
Okay. Thank you.
All right. Bye-bye.
Bye.